drawing the three axes, Y, Z, and X, we can define rotations around each of these axes. A positive Y rotation, positive X rotation, and a positive Z rotation. So, if, for example, I have a man, he is facing in this direction. He's a happy man. Rotating around the Z-axis by 90 degrees, he will be facing this way. Rotating around the Y-axis, taking the initial rotation, then he will be facing, I drew that wrong, in this direction. So that's a Y 90 degree rotation in that direction, and then an X rotation by 90 degrees, taking the initial rotation, then his feet will be facing towards the camera. No, that's wrong. His head will be facing towards the camera. And then his feet will be somewhere up there. Something like that. Okay. And in jME, rotations are defined by Quaternions. Quarter for 4, neons for something else. So they have X, Y, Z, and W components. Quaternions can get quite confusing at first. I didn't really understand them when I first met them, and still don't, if I'm honest. And why are they even useful? Well, first, apparently they're very efficient. They avoid gimbal lock, so you don't lose a degree of freedom if you somehow rotate wrongly. And they can also be multiplied together by vectors to give a new vector rotated by that quaternion. So if I have a vector here at 0, 3, 0, and I have a quaternion defined to rotate minus 45 degrees, then the new vector will be modified by 45 degrees. Nice choice of colour on my part. And quaternions can be multiplied together. It's not commutative, so multiplying quaternion A by B does not equal B times A. So if I have a quaternion, or if I have a character, and I'm going to rotate him in the z-axis by minus 90 degrees. If I have a quaternion defined for that, then you'll first of all be facing this way, and then if I multiply that again, and he will then be facing this way. Okay, let's go see how to use this in jMonkeyEngine. Okay, going to create a new file. Control N. Go to my test template. I'm going to call this rotations. I'm going to create a new spatial variable. I'm going to load our beloved Sinbad model. Model Sinbad. Sinbad.mesh.xml. I'm going to attach it to the root node. And then I'm going to add our sunlight from the palette. One thing you should know is that I've updated the SDK since last time. You can find that by going to Help, check for updates, and then it will check if you need to update it. I suggest you do that. But one thing I'm going to do is get rid of these extra square brackets and normalize local. What this does is it changes the variables already inside the vector3f object instead of creating a new one. So it just helps a little bit. Okay, let's shift F6 and see what we've got. Okay, I'm going to scale Sinbad down a little bit. Set local scale 0.5f. Shift F6 to run it. Click OK. Okay, brilliant. I'm now going to draw some arrows to depict the 3-axis. I'm going to create a private void method to create the arrow. I'm going to assign it a color and a direction. So you can create a new arrow with using the arrow class. Arrow, Control-Shift-I. Using Control Space, I can find what constructor arguments I can put in. I'm going to put in the direction. I'm going to create a new geometry out of the arrow. Arrow, put in the arrow mesh. And then going to Control-Shift-I to fix the imports and then assign the material. No, I need to create a new material. Because each arrow has to have its own material because I'm going to be changing the color. So the asset manager. Stick with the unshaded material definition. I'm going to set the color on it using the set color method. Color, and assign that material to the geometry. Then I will attach them to the roots node. The geometry. Now I'm going to create 3 arrows. I'm going to give the Z-axis a blue color. So I want to say color RGBA dot blue. I'm going to use unit Z vector constant. Going to make the Y color green. Use the unit Y vector constant. I'm going to create the x-axis with a red color. Vector 3f unit x. Okay, let's see what that looks like. Okay, it is there. It's very small, so I'm going to increase the magnitude of the direction by, let's say, 4 times. I'm also going to increase the line width of the arrow. Put a constant of 3 in. Let's have a look at this. Okay, that's a lot better. Okay, going to now add some key mappings so that we can rotate our model using the keys on our keyboard. So going to use the input manager. Going to use add mapping. It takes a string and a trigger. So I'm just going to call this X, and our trigger is going to be a new key trigger, and it takes a key input. We're going to say key Z. Control Shift I to import that. I'm going to add another one for Y. New key trigger, key input dot key Y, and add a final one for the Z-axis. New key trigger, input dot key Z, and I just found I did that one wrong. It should be key X. And the last thing to do is to add the key listener, but I haven't defined this yet. I'm just going to call it